Hello everyone, welcome to the KVP Physics Academy. Today we are going to the study of the collective model. Cell model has been explained many features of nucleons in a ground state and some excited states. However, it plans to explain the large value of electric quadrupole moment in many cases and the deviation of magnetic moment from such a curve makes this model less acceptable. This is the basic two drawbacks of the cell model. This getting whatever the eigenvalue of electric quadrupole moment is a very lower one when we can finding the electric quadrupole moment by experimentally. Means this is not matching of electric quadrupole moment value experimentally and by cell model. Means cell model gives the lower value of electric quadrupole moment. We can find getting the idea of the collective model, then we getting the proper result of experiment. Yes or no? This one is the first drawbacks in cell model. Okay, cell model do not getting the exact electric quadrupole moment value. Okay, and second one is whatever the systematic given the nature of the curve of the magnetic moment, and cell model do not satisfy this one. This is a deviation from this curve, deviation of a magnetic moment from this curve. Okay, this is the basic two drawbacks in cell model, and they Renault in 1950 overcome these two drawbacks. Yes or no? What is the basic assumptions in this case? In collective models, here is two types of nucleons. One is a magic number nucleon, second one is an odd number of nucleon. Magic number of nucleon is a place inner core of a nucleus. This one is the inner core, okay, and the odd nuclei is the outer one. Odd nuclei, outer one. This both is in motion. Inner core also is in motion, outer core also is in motion. This one is a loosely bonded. This outer odd nuclei are loosely bonded. Okay. Now here, an interaction between these two motions or coupling between these two nuclei is a weak. This one is a weak. This is the assumption in a cell model. Okay. But actually this thing is not happened because of this one. Don't getting the exact results of electric quadrupole moment and magnetic moment. Okay. They Renault now overcome this result. How? They explain here attraction between, because of this loosely bonded nucleus create polarization in this stable nuclei or magic number nuclei. Means polarization is take place, and hence because of this one, this coupling is a very stronger one. This coupling is stronger one. Okay, and this coupling is stronger only when this nature, spherical nature, become a spheroid nature. Got it? This one is symmetric with center. Okay, actual in cell model this will be spherical. Okay, but in a model here this one is a deformation in nucleus. Because of deformation we are getting some terms, some extra terms, and this extra term getting the proper result of electric quadrupole moment and magnetic moment of nucleus. Got it? What happened here? Here is the center is a magic number. This one is a more stable atom, more stable nucleus, and this one is a loosely bonded odd nuclei. Okay, and this coupling is a very big, but actually deform this nucleus, and this become a spheroid in nature. Because of spheroid nature here, and because of this odd nuclei, polarization is take place inside the nucleus, and because of this one, this two drawbacks will be overcome. Okay. Now here, what is the total energy here? Total energy is equal to E rotational plus E vibrational plus E nucleic. Okay, and we know that here A rotational and E vibrational energy is present inside the core nucleus. Got it? Idea of the core nucleus and loosely bonded nucleus. Core nucleus means this one is even nuclide, and outer one is a loosely bonded odd nuclei. Got it? Now here, because of this one is a symmetric, all values are even are allowed in this case. Okay. Now E total is equal to E rotational plus E vibrational plus E nucleic. This E nucleic energy getting because of this loosely bonded nucleus, and this two energy getting because of core nucleus. Only for now today, I'll focus only on the rotational one. E rotational. Okay. E rotational. We know that E rotational is equal to 1 by 2 I omega square. E rotational energy is equal to 1 by I omega square. And we know that angular momentum L is equal to how much? L is equal to I omega. Okay. Now suppose here we can multiply it and divide by I. Then we getting 1 by 2 I square omega square upon I. I is the moment of inertia, and we can note down mu r square. Yes or no? By using reduced mass case, mu r square. Okay. 1 by 2 I square omega square by 2. And we know that L is nothing but I omega. Then this can be written as L square upon 2I. And here is a L square can be replaced by J. Then this can be written as J square upon 2I. Then we know that J bar is equal to H cross J into J plus 1. Now substitute this value here. Then we get E rotational. E rotational is equal to, yes, H cross square upon 2I J into J plus 1. This is the rotational energy for collective nature or collective model. In collective model, what is the A energy, rotational energy? H cross square upon 2I J into J plus 1 for this nature. Okay. Now here for this nucleus E1, here is the E1 nucleide. Okay, center core E1 nucleide. Means here is a symmetric with respect to center. Means here only J is a E1 value are allowed. 0, 2, 4, 6 and so on. Okay. And parity is always even. Means J pi is equal to 0 plus, 2 plus, 4 plus, 6 plus and so on. Now in a last case, cell model, we can take the even nucleate 0 plus, but here is a symmetric in nature. We getting the only say is a even value and parity is even 0 plus, 2 plus, 4 plus and so on. Okay. In a ground state, J value is 0. First 2 plus, second 4, 6 and so on. Means you are starting from 0 to 4, 6. Got it? This value. Means your energy is equal to how much there? E rotational is equal to H cross square upon 2I J into J plus 1. And which value are allowed? This is a very important thing. J pi is equal to, yes, always memorize this is equal to 0 plus, 2 plus, 4 plus, 6 plus and so on. So many times we are confused. Here we can take the J value is equal to 0 plus, 1 plus, 2 plus. Don't take like that. Here is only even numbers are allowed. 0, 2, 4, 6 and so on. Once we memorize these two things, first one is a formula and second one is J value, then we can find this a proper answer for these questions. Okay. Now here they are given some energies. Suppose they are given energies of 0, 2.19, suppose 3.14, 4.1 and so on like that. Okay. We know that the initial J value is equal to 0. Next J value 2, next 4, next 6, next 8 and so on. Got it. Now they are given some idea for finding the H cross square upon 2I. In this case, H cross square upon 2I is constant one. Okay. They are given data, initial levels. Okay. Suppose they are given, two energy, how much? 2.19. Okay. And they ask, suppose what is the energy of up to 8 they are given. What is the energy for J is equal to 10 case. Means here first we can find out for given data H cross square upon 2I value, H cross square upon 2I J into J plus 1. Means whatever the given data, choose any one state. as you wish. Okay, means we can choose 2, 4, 6 or 8, anyone for finding the h cross square upon 2i. Here they are given energy, means left side are given. Okay, like that 2.19 is equal to h cross square upon 2i, h cross square upon 2i, j into j plus 1. Suppose what is the value of j here? J is equal to 2. 2 into 2 plus 1, 3. 3 into 2, 6. Means what is the h cross square upon 2i value? H cross square upon 2i value is equal to how much? 2.19 upon 6. 2.19 upon 6. Got it? Means we are getting h cross square upon 2i value from given data. Okay. Once you are getting this one, we need to find out what is the value of E10. E10 is equal to, yes, h cross square upon 2i, j into j plus 1. Okay. We know that for 10 state, j value is equal to 10. Means 10 plus 1, 11. 11 to 10. Okay. We are getting this value. What is the value of h cross square upon 2i? We cannot use this relation. We cannot find out the h cross square upon 2i value. Hence, initial data only used for finding the h cross square upon 2i value. Now this value substitute here. We are getting the answer for E10 state. Got it? Means whatever the given data, first find out the h cross square upon 2i. And next do whatever they ask. This is a very simple question in a SET exam and NET and GATE exam. Okay, once you know the formula, directly we are getting 5 marks in NET also. Okay, but what is the confusion here? Confusion is that only we cannot memorize. Here is a 0 plus 2 plus 4 plus value. In exam, you are confused only in a j values. Suppose they are given, 2 plus energy is equal to something. What is the next state energy? And directly we can take the 3. No any one option is matches here. Got it? Means 2 plus after 4, 4 after 6 and so on. Okay. Now we can take some problem for this case. Find the energy of 12 rotational. Find the rotational energy for. Find the energy for 12th state. For 12th state. Find the rotational energy. Find the rotational energy. Find the rotational energy for 12th state. Okay. What is the format for this question? Already I can say that. First we can, whatever the data are given, first find out the h cross square upon 2i value. Okay. Here for 2 states they are given energy is equal to 0.1. 4 states they are given the 0.329 state. Next 6 state they are given energy is equal to 0.6 set. Okay. Now we know that what is the rotational formula? Rotational energy is equal to h cross square upon 2i. H cross square upon 2i j into z plus 1. That's what j into z plus 1. Now for first aim to find out the h cross square upon 2i value. Okay. From which values? From given data. What is the given data? Here 2, j is equal to energy. J is equal to energy. E is equal to 0.2 mega electron volt. 0.2 mega electron volt. For what value of J? J is equal to, energy is equal to this one. Now our aim to finding the what is the energy of the 12th state. What is the energy for 12th state? Means what J is equal to 12. What is the energy? What is the energy for this case? Now, okay, using the initial data, E is equal to, yes, h cross square upon 2i, J into J plus 1. J into J plus 1. First one, J is equal to 2 into 2 plus 1. 3 into 2, 6. This is equal to h cross square upon 2i into 6. What is the energy? 0.1. Means what is the value of h cross square upon 2i? H cross square upon 2i is equal to 0.1 upon 6. 0.1 upon 6. 0.1 upon 6. This is the value of h cross square upon 2i. H cross square upon 2i. Now, our aim finding the 12th state means write down the E12 is equal to h cross square upon 2i. H cross square upon 2i. Okay. Substitute J value. What is the J value here? 12 into 12 plus 1. Okay. 12 plus 1, 13. 13 into 12. What is the h cross square upon 2i? 0.1 upon 6 into 12 into 13. 13, 12. 12 into 3, 36. Sorry. 36. Okay, 3 is here. 12 plus 156. Okay, Bagile. Okay, 3, 2, 3, 5, 3, 2. Yes or no? 52. 52, 26. 26 into 0.1. 0.1 into 26. How much? 2.6. 2.6 mega electron volt. Means what is the energy of E12? What is the energy of E12? Energy of E12 is equal to 2.6 into 2.6 mega electron volt. Okay. How to solve this problem? First, always memorize J value, always starting from 0, 2, 4, and so on. This is the J value for even nuclide. Even nuclide, collective model always memorize. Collective model is a even nuclide model. And always J value is equal to 0, 2, 4, 6, and so on. And parity is even. Parity is even. Next, second one is formula. H cross square upon 2i, J into J plus 1. Next, our aim to finding the H cross square upon 2i. How? Taking the given data. Means, in exam, any exam, they are given the initial data, no problem. We don't need to finding the what is the value of H cross square upon 2i without any given data. They are always given some data. And always memorize. They need to find the H cross square upon 2i value. Definitely we need to some data is a must. Without data we cannot find out the H cross square upon 2i value. Okay. First focus on whatever the given is data. Then analyze this data and finding the H cross square upon 2i. Just to substitute to this value, we getting the answer. The single particle energy difference between p orbital, p3 by 2 and p1 by 2 of a nucleus 50SN114 is 3 mega electron volt. The energy difference between the state in its first F or 1F orbitals. First one is 7 minus 7 plus 5 minus 5. Okay, which of the following option is correct one? अब देखिए कलेक्टिव मॉडल में आपको एक ही फॉर्मूला याद रखना भाई. इस बस घुमा फिरा के पूछ सकते हैं और कुछ नहीं कर सकते इसमें. बस एक ही फॉर्मूला है, बस आपको उन्हीं को यूज करना है, इससे ही सॉल्व करना है. दैट्स इट. अब देखिए क्या पूछा, थोड़ा सा घूम के उन्होंने आंसर दिया. देखिए कैसे घुमाया उन्होंने. आपने दिया क्या है, द सिंगल पार्टिकल एनर्जी डिफरेंस बिटवीन p orbitals. Okay, here we can study the nuclear p orbitals. Splitting first state is not a 2p1 by 2. Here is a 2p 3 by 2. 2p 3 by 2 have lower energy. 2p1 by 2 have higher energy. Yes or no? P splitting in these two forms. Okay, and what is the energy difference for this case? 3 mega electron volt. What is the difference? 3 mega electron volt for this case. Now we know that what is the formula, delta E. Delta E is equal to H cross square upon 2i. H cross square upon 2i as J into J plus 1. J into J plus 1. Okay. Higher minus, no? Higher is in this case we can take the 3 is higher. Here we are getting the negative sign. Okay. J into J plus 1. 3 by 2 into 3 by 2 plus 1 minus 1 by 2 into 1 by 2 plus 1. Okay. Then what is the value of this is equal to how much? H cross square upon 2i. Okay. 3 plus 2, 5 into 3, 15 by 4 minus 15 by 4 minus 1 by 2 plus 1, 3 by 2, 3 by 2 into 1 by 2, 3 by 4, 3 by 4. 15 minus 3, 12. This is equal to how much? H cross square upon 2i, 12 upon 4. 12 upon 4 is nothing but 3. And here, how much? Difference in energy, delta is equal to 3 mega electron volt. 3 mega electron volt. Means what is the value of H cross square upon 2i? H cross square upon 2i is equal to 1 mega electron volt. 1 mega electron volt. Okay, this is the H cross square upon 2i value. Initial one. We know that whatever the given data is for finding only H cross square upon 2i value. Next one. Take for finding the 1f. 1f is equal to H cross square upon 2i. H cross square upon 2i. What is the f value? F value 7 F, we know that F cell containing total maximum number of electrons 14, maximum number of electrons 14, okay, and we know that F contains the electron 15, okay, but here is a nuclear 15 protons or neutrons, sorry 14, 15, 14, okay, 15, 14 half 7 means F 7 by 2 level, and second was what is the remaining 6 means 5, F 5 by 2, 5 by 2 means first take the 7, 7 by 2 into 7 by 2 plus 1 minus 5 by 2 into 5 by 2 plus 1, 5 by 2 plus 1, okay. Delta 1 EF, delta E 1F is equal to H cross square upon 2I, okay. 7 plus 1 by 7 by 2 plus 1, 7 plus 2 9, 9 by 2 into 7, 9 into 7 63, 63 by 4, 63 by 4, and second one is 5 plus 2 7, 7 into 5 35, 35 by 4, 35 by 4, okay. 63 minus 35 28, 28, yes or no? Then what is the value of H cross square upon 2I? H cross square upon 2I is equal to 1. How much? 1, okay. And here is a 28 by 4, 28 by 4, 28 by 4 is equal to how much? 7 mega electron volt. 7 mega electron volt. This is a very simple one. Always memorize. Okay, delta is equal to H cross square upon 2I Z into Z plus 1. Okay, this is the Z value for P orbital 3 by 2 and 1 by 2. And F value we have containing the maximum 40 number means 7 by 2 and 5 by 2 Z value. Take only difference of this one, we getting the value of H cross square upon 2I into. Once you getting H cross square upon 2I, focus on whatever they ask and take the formula and substitute whatever the given data here. Then we getting delta 1F, but here this one is unknown, but this value finding from using the initial data. Substitute this value, we getting the answer for this question. What is the next energy? Next formula. A permanently deformed U1 nucleus with a Z pi is equal to 2 plus has the rotational energy 93 kilo electron volt. The energy of the next excited state. Here, permanently deformed with the E1 nucleus. E1 nucleus is related with E1 nucleus is related with the collective model. Okay, yes or no? Collective model. In collective model, we know that one formula. Which formula? E is equal to H cross square upon 2I Z into Z plus 1. Okay, J into Z plus 1. What is the given data? Finding H cross square upon 2I value. The performing nucleus with a Z pi is equal to 2 plus. Yes or no? How much? 2 plus. Means here J value is equal to 2. Parent is equal to E1. E1 for E1 nucleus. Okay. Next, they are given the 2 plus energy is equal to 93 kilo electron volt. Means E2 is equal to 93 keV kilo electron volt. Now our aim to finding the next state energy. We know that ground state 0, next 2, next 4, next 6. Okay? Here 0 energy 0, 93 keV. And our aim to finding the next state energy for J is equal to 4 plus. Okay? For next state J is equal to how much? J is equal to 4. This is a very important. Not a J is equal to 3 now. J is equal to, we can substitute J is equal to 3. No any one option matches. Okay? All are different options from this. Okay, J is equal to 4. H is equal to, means E4 is equal to H cross square upon 2I J into J plus 1. Means 4 into 4 plus 1. Okay. H cross square upon 2I, 4 into 4 plus 1, 5 plus 4, 20. How much? 20. We cannot getting the direct answer. Okay, here we need to H cross square upon 2I value also. How to find out this one? Using E2. E2 is equal to H cross square upon 2I, 2 into 2 plus 1, 2 into 2 plus 1. Okay, 2 plus 1, 3, 3 into 2, 6. Means H cross square upon 2I is equal to, yes, energy 93 upon 6, 93 upon 6. Don't solve this one. Directly write down H cross square upon 2I is equal to 93 upon 6. 93 upon 6 into 20 into 20. 6, 3.2, 3.33. Okay, 3.33. 93 into 3. 93 into 3. 9. 93, 9. No, 1 minute. 24 plus 20 h cross square upon 2I into j plus 1. For 20 h cross square upon 2I. 93 upon 6. Okay. H cross square upon 2I is equal to 93 upon 93 upon 6. Okay. 93 upon 6. Or you can solve here. 3, 3, 2. Okay. 3, 3, 1. Means here is a 31 upon 2 into 22, 10. Okay. Means 31 into 10. 31 into 10. How much? 2, 1. 310. This is equal to how much? 310. Is what is the energy of the next state? E4 is equal to. Yes. E4 is equal to how much? 310 keV. Why we can write down the here keV? Because initial energy they are also given in a kilo electron volt. Hence we can write down the final answer. Okay. Got it? This is the deform given nucleus with the J pi is equal to 2 plus. Means they are given data J pi is equal to 2 plus. This state. And next state for this system, this J is equal to 4 pi is. Okay. Next state J is equal to 4. Finding for h cross square upon 2I given the initial data. H cross square upon 2I is equal to energy upon J into J plus value. Okay. Substitute here we are getting the h cross square upon 2I. We need to find out what is the energy for J is equal to 4 values. Substitute here, substitute h cross square upon 2I value. We are getting the direct answer for this question. Next problem. The excited state of W182 is a 2 plus and a 0.1 energy. 0.1 energy. Above the ground state, estimate energy level of next two energy levels. Okay. Estimate the next two energy levels energy. Okay. They are given data. There is a 2 plus energy is a 0.1, 0.2, 1 electron volt. And let's find out the next two energy levels energy. What is the next two energy levels? Next two energy levels is a 4 and 6. J is equal to 4 and 6. J is equal to energy is a 0.1 electron volt. J is equal to 2 energy. E2 is equal to 0.1 electron volt. E2 means here is not a second energy. Okay, this one is a first energy. Then we know that formula E is equal to h cross square upon 2I J into J plus 1. Okay, for J is equal to 2 case, energy 0.1 is equal to h cross square upon 2I 2 into 2 plus 1. 2 into 2 plus 1. 2 into 2 plus 1, 6 means h cross square upon 2I is equal to how much? Is equal to 0.1 upon 6. 0.1 upon 6. Don't do any calculation for this case, write down as it is. Next we can find out next state. Next state means next state J is equal to how much? 4. J is equal to 4 means E4 is equal to h cross square upon 2I 4 into 4 plus 1. 4 into 4 plus 1. 4 into 4 plus 1, 20. Okay, means E4 is equal to h cross square upon 2I into 20 into how much? 20. Then E4 is equal to 20 h cross square upon 2I 0.1 upon 6 into 20 into how much? 20. Yes or no? 0.1 upon 6 into 20. 10. 1.0 upon 3. 1.0 means this is a 1 by 6, 1 by 3, 1 by 3. 10 by 3 means 0.3. We can take next, no problem. E4 we getting, E4 is equal to, yes, 0.3 electron volt, 0.3 electron volt. Next for E6, E6 is equal to, yes, E6 is equal to H cross square upon 2I. What is the value of J? 6 plus 1. 6 into 6 plus 1. Okay, this can be written as H cross square upon 2I. 6 into, write down here 7. Why we can write down the 6 into 7? Why we not write down the 42 here? Because here is we getting 0.1 upon 6. Got it? Next, E6 is equal to, what is the H cross square upon 2I? 0.1 upon 6 into 7. 6 is get cancelled. Okay, 0.1 into 7. 0.1 into 7 is equal to how much? 7 electron volt. 7 electron volt. E6 is equal to this one. Okay, got it. Now summary of this lecture. Summary of this lecture is that we know that the cell model explains the so many features of nucleus, but some drawbacks also. What is the drawback? They do not give the proper idea or proper result of electric quadrupole moment, because experimental and using cell model, this variation electric quadrupole moment answer is a variation. Okay, and second one is a magnetic moment does not matches with the cytomatic curve. This is a variation or divergence, deviation from this curve. Yes or no? This is the basic drawbacks, and this is overcome using the zeronotter by which concept? Deformation concept. Deformation concept. Okay. Here is the center, have the core nucleus and loosely bonded or nuclei. Okay. And here is a weak interaction, but some result is not satisfactory, and this in a ellipsoid nature or a spheroid nature. Here this one is the center, and all in a equal distance or symmetric in nature. Hence we can take the J value is equal to 2, 4, 6. Okay, and so on. And this is the loosely bonded. Okay, and the motion between the loosely bonded and core nucleus taking the polarization inside the stable nuclei or core nuclei. Okay, and this core nuclear polarization gives the result or getting the some extra terms, and this extra term satisfy the electric quadrupole moment and magnetic moment. Perfect result. Got it? This one is the spheroid nature, spheroidal nature of the core nucleus, and all the nuclei whose are loosely bonded. Okay, both is in motion, no problem. And loosely bonded all nuclei gives the E nucleic energy.